this video, I'm going to talk about the remainder theorem. According to the remainder theorem, when a polynomial px is divided by ax plus b, then the remainder is p negative b over a. So what is negative b over a? For the divisor ax plus b, when the divisor ax plus b is equal to 0, then x is equal to negative b over a. So when we substitute this negative b over a into the value of x in this polynomial, after calculate, so we will get a value, then that value is the remainder. So for example, we have a polynomial px here. When this polynomial is divided by x minus 2, so when x minus 2 equals 0, so x is equal to 2. So now I'm going to substitute the value of x in this polynomial with 2. After calculate, we find that the value is 4. So therefore, the remainder is 4 when this polynomial is divided by x minus 2. Now I'm going to show you how to use the remainder theorem in solving the problems involving polynomial. Now a polynomial px is defined as here, where a and b are constants. Given that the remainder when px is divided by x plus 1 and x plus 2 are 0 and negative 4 respectively, find the value of a and b. So from the question, we know that when px is divided by x plus 1, the remainder is equal to 0. Based on the remainder theorem, this can be written as p negative 1 equals 0. And we also know that when px is divided by x plus 2, the remainder is negative 4. So from here and based on the remainder theorem, this can be written as p negative 2 equals negative 4. And we are going to find the value of a and b, where a and b are constants in this polynomial. And based on the first information, now I'm going to substitute x with negative 1 into this polynomial. So when I substitute x with negative 1 into the polynomial, so the value should be equal to 0. So I write down it is equal to 0. Then when I simplify this equation, I find that that is a plus b equals 16. Now from the second information, when I substitute negative 2 into the polynomial here, I should get a value negative 4. Now I write negative 4 on the right hand side here. So when I simplify this part, and I'll get 4a plus b equals 34. So now I have two linear equations. So by using these two linear equations, I'm going to do simultaneous equation to find the value of a and b. So for this one, I'm going to use the second equation minus the first equation, where 4a minus a is 3a, b minus b is 0, 34 minus 16 is 18. So now I get a is 6. So now I'm going to substitute a equals 6 into the first equation. Then I get b equals 10. So therefore, a is 6 and b is 10. Now let's try this question. When the polynomial px is divided by x minus 1, its remainder is 5. And when the polynomial px is divided by x minus 2, its remainder is 7. Now find the remainder when px is divided by this quadratic expression. Now from the first statement here, when px is divided by x minus 1, its remainder is 5. Now based on the remainder theorem, we can write this one as p1 equals 5. For the second statement, when px is divided by x minus 2, its remainder is 7. And based on the remainder theorem, this one can be written as p2 equals 7. And now we are going to find the remainder when the polynomial is divided by this quadratic expression. Since in this question, the polynomial px is not given, so now I'm going to construct the polynomial based on what we have learned before, that is when a polynomial is divided by a divisor. From the result, we know that the polynomial is equal to the divisor times the quotient plus remainder. For this question, the polynomial is unknown, so we simply write down the polynomial as px. And the divisor for this question is this quadratic expression. So the divisor is x power 2 minus 3x plus 2. And quotient is unknown, so we simply use a q to represent the quotient. And we know that when the divisor is a quadratic, then the remainder should be a linear. So since linear we do not know, then we simply use the unknown form to represent the linear remainder. For this quotient, since the polynomial is unknown and we do not know the degree of this polynomial, so means the quotient also we do not know the degree. So we simply use the p and the q to represent the polynomial and the quotient. So before I move on, I'm going to factorize this quadratic, and I find that it is equal to x minus 1 and x plus 2. So these two factor is given in the question. And from the first information, now I'm going to substitute x with 1 into this polynomial. So when I substitute x with 1, this x with 1, and from the calculation I should get 5. So I write down equals 5 here. Now for this part, even though we do not know what is the quotient, but since this one 1 minus 1, it should be equal to 0, then 0 multiplied with everything, this part will become 0. So now I will get a plus b equals 5. So next, I'm going to substitute x with 2 into this polynomial. So when I substitute x with 2, and I find that the answer should be equal to 7. So I write down equals 7 on the right hand side. And for this part, even though we do not know what is q, and since 2 minus 2 is equal to 0, so means this whole part will be equal to 0. And then I'll get 2a plus b equals 7. Now I have got two linear equations here. So now I'm going to do simultaneous equation in order to find the value of a and b. So to do that, I'm going to use equation 2 minus equation 1. Then 2a minus a is a. 7 minus 5 is 2, so a is equal to 2. b minus b is definitely is equal to 0. Now I'm going to substitute this value of a into the first equation. So now I get b is equal to 3. And since the question asks for the remainder, so remainder, since just now remainder is a x plus b. So when I substitute a with 2, b with 3, so therefore the remainder is equal to 2x plus 3. Now let's try this question. When this polynomial is divided by x minus 1 times x plus 2, the remainder is 2x plus 7. Find the value of p and q. So first, I try to write this polynomial in function notation px. Actually, for this question, we can use other method to solve it. In my previous video, I use equating the coefficient to solve this question. So now, if I want to use the remainder theorem to solve this question, based on the remainder theorem, the divisor is a linear divisor. But for this question, the divisor is a quadratic divisor. So if we want to use the remainder theorem to solve this question, so first step, I'm going to separate the divisor into two. First, I try to divide the polynomial by using the divisor x minus 1. Then, I try to divide the polynomial with the second divisor, that is x plus 2. So, for the first divisor, x minus 1, when px is divided by this linear divisor, and based on the remainder theorem, I can replace x with 1. And when I replace x with 1 into this polynomial and I simplify, then I find that it is p plus q plus 6. So this is the remainder of the polynomial when this polynomial is divided by x minus 1. And when this polynomial is divided by x plus 2, and we replace x with negative 2 and substitute this x with negative 2, and when I simplify, I get 4p minus 2q minus 3. So this is the remainder when the polynomial is divided by x plus 2. Now, after we have got this information, and now since this question involving polynomial division, and we know that the result of the polynomial division can be written as polynomial equals divisor times quotient plus remainder. For this question, polynomial is px, divisor is the quadratic divisor. Quotient, since we do not know the quotient, so for time being, we use qx to represent the unknown quotient. And the remainder is 2x plus 7. For this question, even though the polynomial is given, but we do not know what is the value of p and q, so now I'm not going to list down the polynomial. Instead of that, I use px to represent the polynomial. Now, from the first information, I know that I'm going to substitute x with 1 into this equation. So when I substitute x with 1 into this equation, and I know that the result should be equal to p plus q plus 6. So I write down the result on the right hand side here. And for this part, even though we do not know the quotient for qx, but 1 plus 1 is equal to 0. So since this one is equal to 0, so the whole part is equal to 0. So for this part, when I simplify, I get p plus q equals 3. Then from the second information, I know that I'm going to substitute x with negative 2 into this equation. So once I substitute x with negative 2 into this equation, I know that p negative 2 should be equal to 4p minus 2q minus 3. So I write down the result on the right hand side here. And for this part, since negative 2 plus 2 is equal to 0, so means the whole part here is equal to 0. So for the rest of the part, when I simplify, I get 4p minus 2q equals 6. From this calculation, now I got two linear equations. Now I'm going to do the simultaneous equation in order to get the value of p and q. So first, I multiply the first equation with 2. Then, I use second equation plus the third equation in order to eliminate the q term. Then I get 4p equals 12. Then from here, p is equal to 2. Now I substitute p equals 2 into the first equation. Now I get q is equal to 1. So therefore, P is equal to 2 and Q is equal to 1. I think that's all for now. If you feel that this video is beneficial, please give me a like and share to your friends. Thanks for watching.